Well, good morning, everyone. I'll start off by presenting a little bit of who is CEMEX, who are we. CEMEX is a global building materials company that provides high-quality products and reliable services to communities and customers in more than 50 countries throughout the world. We have annual sales close to $14 billion, more than 40,000 employees. We have an installed capacity of more than 90 million tons per year. On the aggregate side, 150 million tons capacity. And in concrete or ready mix, it's over 50 million cubic meters per year. I'll start with presenting myself. My name is Rodrigo Quintero. I am the Operations Digital Technologies Manager at CEMEX. I'm part of the corporate group. That part of my role is to take care of the PI infrastructure, to have all the digital platforms, how to interconnect that on the cement operations side we use. That's PI, SAP, health and safety platforms, and their interaction, so on. Nowadays, with the advent of these new technologies, including machine learning and advanced analytics and so on, we're including those in from base. Prabal, I don't know if you want to present yourself.
Thank you. My name is Prabal Acharyya. I'm glad to be here. I'm with Petuum, and I'll come back once Rodrigo finishes. There's plenty of seats in the front. Please come forward. Actually, he is here.
Thank you, Prabal. Okay, so a little bit the agenda for this talk. First, we'll talk about the artificial intelligence and the potential we saw for cement industry. In CEMEX, how we started on this path to the AI, to using AI, and an overview of the Petuum and Petuum Industrial AI product that they have. We'll go on a little bit, talk about our journey on how we got or how we are moving ahead with an auto steer or an autopilot for our cement plants in one of the sections of the kiln. And then I'll hand over the mic to Prabal to talk a little bit about architecture and thing with PI. So start a little bit about, yesterday we were talking about journeys and the vision. One of the journey began probably, I can say, about 10 years ago. We already had PI installed. Well, more than 15 years ago, we have already PI installed, and that's where all the digitation starts. We are gathering data. We have tons of data, and as we have seen in previous PI World conferences, that's pretty much a gold mine sitting there waiting to be tapped and extracted and used. And today, we are still not using that as we should or as much as we would like. Part of this journey or this transformation effort, we had many different fronts, but in this particular one, we already have the connectivity. We already have all the data in. We're using it for reporting, for transactional information, but not to really improve the process or take it to the next level. So once we started doing some additional efforts to gather more knowledge on our data about our process, how process can be improved, getting more usage of data, deeper analysis, bringing or developing capability in our to really have a better understanding and seeing what's going on with the process. And when we started with Petuum, it was, okay, I have some understanding, but I want to see if this technology can serve me. We had already started doing some linear modeling on the advanced analytics side, and even though we got good results, that was not quite what we were expecting, so we wanted to take it to the next level, and we wanted to see if machine learning could do that for us. After we did that, we went all the way down to the next step, which was to get an autonomous operation. And that's where Petuum's process came in really good. So I'll start moving into the, in summary, and this is just a very brief introduction. The first step was to get connected and then to get the prescriptive and understanding and recommendations on how to operate, finalize with autonomous operations. So why artificial intelligence? Why we wanted to move from advanced analytics to artificial intelligence? We really believe, and there's a lot of literature around this, that artificial intelligence is the key to future growth and success. And either you get on board, okay. No problem. Anyways.
They don't want you to speak.
Okay, perfect. Can you hear me now? Yeah.
Yes, sir. Yes.
So at the end, I will be able to say, "I'll drop the mic." Thank you. Anyways, so there's a lot of literature around this, and we said the artificial intelligence really holds the key to future growth and success. And we wanted to take our operations to the next level using this technology to help improvements in our operations from the operational side, maintenance side, safety performance, energy efficiency, and so on. So those things, it's not that our people are incapable of doing it, but with advanced analytics and artificial intelligence and machine learning, we can take the best days that we have in operations and make them repeatable every single day to have those identified golden days in operation to be more consistent and more repeatable every single day. So once we started looking at different possible applications or potential applications, we saw two main roads. One on the maintenance side, on the failure prediction side, and the other road was to follow the process optimization side. And in here, we would like to do everything. In the end, resources are limited. Data quality is an issue, so we may have better quality in one side of the road than on the other side. So we had to decide where we had better data to start doing or to start traveling in this path. So we decided to go through the process optimization side. But definitely there are a lot of uses in failure prediction and predictive maintenance, in product design and quality. So there's a lot of different use cases that can be applied. So yesterday we were listening to Mark Jeffries saying we need to have a vision, and we not on everybody tells you the vision and not the journey. This talk is about the journey, but I need to tell you the vision. The vision, we set a goal for in 4 years, 3 years ahead of this was last year, so 4 years ahead of time. We wanted a full cement kiln in autonomous by 2022. Hopefully, we will achieve that sooner, but in the end, we want to obtain or to achieve a point where we have empowered operations by AI. So it's not that the people will be able to do their job better, more efficiently, being empowered by artificial intelligence. This will allow us to achieve increased efficiencies, reduce fuel and efficiency consumption, better quality, reduce cost, and obviously better reliability on our equipment. So, and this takes us on the start of this journey a year ago. It started here in Pi World last year, where we met between CEMEX and Petuum. So it has been a long journey now, very good experience working with Petuum. We started engaging with them, analyzing our data. We didn't know, we knew what the vision was, where we wanted to get, but we didn't have the exact idea on how to travel that path. So we started with number one, what we had already did or what we had already done with with linear modeling, and that was with prediction. So we said we want to have real-time prediction using machine learning. Let's see if this does what we have already done, and if it does it better. So we wanted to test the technology. Then after we had that, we went to the second stage. This was a phase approach. The second phase that was developed or evolved as time passed was to get the prescriptions. If we had already a forecast of the process on how it was going to behave, instead of having the operator make the decisions, suggest improvements to the operator. And the first one, in the third stage, if we already have a prescription or a recommendation, take it to the next level and feed it directly to the kiln. So to tell you about, I don't know if you have been to a cement plant or know how the process is, just a brief introduction. This is the whole kiln system. We have a preheater tower, then the kiln itself, this is the crucial part, and then the clinker cooler. The feed rate, it comes from the top to the bottom, starts heating on the way down, then comes to the kiln. It finishes converting from raw material to clinker, which is the base material for producing cement. And then, as it comes down here, it's about 1,500, 1,300 Celsius degrees. It has to be cooled down before it leaves the system, so that's the job for the cooler. But also, the cooler functions as a heat exchanger. It extracts all that excess heat from the clinker and puts it back into the system. So we don't have to spend a lot of energy heating the air and heating everything, because the air coming into the system is already hot from the cooler. So the idea, of course, the vision that we have is to have everything being autonomous. But for testing out the technology, we needed to start with a small portion of it. We needed to start small to test if the technology can do this for us, and if possible, or if successful, then scale up to include our other sections of the kiln. So we selected the cooler. It's I would say it's a fairly simple process to control, easier than the other ones. My guys from CEMEX are making faces at me. Well, in reality, it's a very complex process. But from the other options, I think this one was the easiest one to deploy. So we started out with the cooler section, and our goal from here, the air comes out in different ways. It has 3 different main outstreams. So the goal was to maximize the heat in the air going out of the cooler and to minimize the exit temperature of the material. The controllable variables are pretty much the air flows, from the fan flows or the pressures that we have here, and the grate pressure and grate speed that moves the material out of the system. And of course, there are too many other factors. Just to list a few, we have the material chemistry, the feed rate, burning some temperature, kiln amps, because this determines how fast the material is coming into the kiln, into the cooler. In total, I think this model has about 40 or more significant variables that interact and have an impact on how the process works. So even though it's a day-to-day operation for our cement operators or kiln operators to be doing this, to do it on a consistent basis, day through after day, is not an easy task, and we need some algorithm to make it work better and more consistently. So going into how we achieved that, in the first phase, and that was the very first test, it was, okay, predict me or help me with the prediction on how the material or the system is behaving. So we were able to identify the output variables behavior very well, I would say, between 5 and 15 minutes, up to 25 minutes, you're still okay. Beyond 25 minutes, then it starts diverging. But the very interesting part of it was that we were able not only to predict ahead of time the temperature with a very small error, but also the changes in slope. And to us, this was impressive. Getting this information beforehand, even 5 to 10 minutes ahead of time to the kiln operator makes a huge difference, because now they know what to expect and how to prepare for this. Right now, this is only, or it used to be only reactive after the fact, but having this ahead of time makes a huge difference. So when we first saw this, we said, wow, this is something beyond what we ever had. So we asked Petuum and the team. I mean, and I need to say the team because it's Petuum, it's a CEMEX team. We have our subject matter expert, our machine, or our data scientist from Petuum. It's a big team working on this. It's not a minor effort. I say, okay, you are giving me the forecast or the prediction on how the system is behaving. Can you give me sensible recommendations on how to operate? Because right now, all the actionable items rely on the operator's knowledge. And every kiln operator is trained differently, or they behave differently on how they, I mean, we're all human beings and we have different ways of riding a bike. So the request to Petuum is, now you have given me the forecast, can you help me with some recommendations on how to operate? What actions are the ones that the operation needs to make in the system? So we moved on to the second stage, or to the second phase, which was give me the prescriptive recommendations. Just as when you go to a doctor and they give you, okay, take this medicine and it will help you get better. This is exactly the same. We have recommendations, and it's up to the patient to decide to take it or not. So we cannot force them onto the kiln operator, but at least they are supporting the operation. The way we started doing this is they had some recommendation, as it was up to them to feed them into the system. And they were given new recommendations every 5 minutes. So if you are receiving 10 different set points, and then you start comparing, I have a set point of 10. Is it good enough or not? Is it reasonable? Is it too high, too low? So by the time the kiln operator decided to input or to validate if that was a good recommendation or not, it took more than the 5 minutes that the system was feeding them. So we started with 15 minutes manual recommendations, and we said, okay, this isn't working. We need, first of all, we need a better way to validate if the recommendations are sound. So we added some screens to add to determine if the recommendations were sound or not. So we have a box plot to say, okay, this is the way you've been operating, and this is within range or not. So after that, it was really easy for the operator to say, or well, not really easy, but easier to say, this is a sound recommendation and I will put it into the system. And then they had to type everything manually. So that led us to the third stage, which was, if we are already doing that, if you have already solved the hard part, let's connect it to the system, feed it directly to the system. That's the easy part, because you solved all the hard work before. So the third part is to connect it directly to the system. So we have now a way in the control system for have an auto steer on, just like the one you have in your cars that you are driving at 50 miles an hour, and you say, okay, want cruise control, turn it on, and then you forget about it, and that's it. So this is really good. So in this case, the operator is still there. He can supervise the recommendations and he can work on it. But the change, this is, I mean, this slide will tell you everything. The moment the auto steer mode goes on, you can see directly improving. So, I mean, this is really exciting, and I don't know if I can portray this, my excitement good enough. This is like when you first, when you were a child, remember when you learned to drive a bike or to ride a bike. The first time you rode a bike without any help, you had that adrenaline rush. This is the same. When you have an AI model running the system for you, first time ever, it's something out of this world, and that's the feeling that we had, really. So our achievements. In the first phase one, we were able to forecast prediction in real time. Phase two, we were able to achieve prescriptive recommendations in real time. And in phase three, we were able to successfully have the auto-steer operations in a cement kiln. And I marked the date here. Internally, this slide, we've been using it in CEMEX since November 27 of last year, because that was the first day we achieved this. So it was, to us, it was a historic date because we are changing the way we operate, and that's the beginning of a journey. A very amazing and exciting journey. So to tell you how this works, I'm gonna hand off the mic to Prabal, who has all the technical knowledge on this.
Can you hear me here? Okay, I'm good. I'm good. Okay. Thank you, Rodrigo. That's a great. This is a great together. I still need them not switching this on. Can you hear me okay? So it has been a great day, that November 27. We have been working for quite some months before that. But together we'll show you quickly what we're doing here. But tomorrow we also have a session where we can go deeper into any of these Petuum Industrial AI Autopilot. So from left to right, the control system, we actually use OSIsoft Pi infrastructure for bidirectional connectivity. We're using the OPC. I'll go into a different slide. But what's interesting is that all the three modes that he was talking about, the prescribe or forecasting, the predict mode, then the prescribe mode and the auto steer, all runs through this entire end-to-end system. So we are not doing anything. The industrial part of this, the industrialization of AI has already happened. And so if I go into the next slide, you'll actually see what we do. So we are Petuum. We're an AI platform company. We're coming from a great set of co-founders. We're coming in from the Carnegie Mellon things. Our co-founders, Eric Zhang and Chirang Ho, are both here. We headquartered in Pittsburgh, and we also have an office here in Silicon Valley. So AI as civil engineering. I don't know whether you actually heard this thing. We have moved from AI being just an artisanship or somebody just doing a great AI model, a great ML model, and putting it in production. Those days are actually past. So we can now actually, with working with CEMEX, which we are showing here, is that you can actually deploy this autopilot, auto steer at scale across your enterprise, not just for one asset, not one cooler, but across 57 plants, 75 lines, with the pyro process, with the ball mills, vertical mills, all the things that we are working together. And how we are able to achieve that? Through our platform, the Petuum AI platform, and I'll go into a little bit more detail after that. So as the Petuum Industrial AI Autopilot, in this slide, you will see from left to right, first thing is the customer network. We know in this here, you all have Pi system, or you're deploying it, or you're thinking about it. In CEMEX's case, they already had it. So that actually helped us a lot. Immediately from there, we took the time series data, but we also connected to some of the unstructured and the structured databases. We've been working with some of the images, some of the videos. All those things are captured and comes to our Symphony AI platform. That's where all the data aggregation, all of things happens. That's where the autopilot products are built, or the modules are built. So the cooler he has been talking about actually is an asset autopilot for us. And if I take the cooler, preheater, and the kiln, then it becomes a pyro process. That's what the process autopilot is about. And then we have some operational excellence initiatives. And I'll go into more detail tomorrow and also come and talk to us. I won't take the thunder. But one of the things I want to say here in this slide is that when you are actually deploying at scale, you need a lot of these enterprise processes. For example, self-learning. We have deployed this on November 27, the cooler autopilot in one of the plants, and I can see Edmo right here working with his team. But today, here in April, it's still running every day. They are switching it on. But the data has changed. A lot of sensors have changed. Those self-learning is very, very important. So even though you can actually create an AI algorithm, an AI model, you actually need a platform to make that to the same level. You need to build the enterprise capability while you are doing the pilot. It's not an afterthought. So that's what we bring in. And the 3 phases that Rodrigo was talking about, the predictions, prescription, and autosteer, are actually modes in our product. So end-to-end, from the left, the data on the edge, on-premise, and on the cloud, we connect with OSIsoft. And then finally, this is how it looks like from our side. Again, this is a drawing, this is not the exact thing. But remember the slide he was showing about, that the cooler and the kiln? This is inside the system. We have some controls, we have some objectives and constraints, and look at the data flows from Pi, and in this case, there was an unstructured database, and the 3 modes. Let me give you a couple of things about the OSIsoft integration. So very seamless integration. We started from the very first day. The enterprise infrastructure was already in place. We didn't have to spend any time in the data collection part, how we got the data from our side. We use Pi Web API. We use the connectors. First of all, for bidirectional connectivity, they had to deploy the Pi OPC read-write, but that was, again, seamless. As part of our edge, which is the auto steer part. By the way, auto steer, I want to just explain a couple of things here. The 3 phases that we talked about, don't think that auto steer means that it's actually being steering. It's more like guide rails. The operator is still there. The operator is a supervisory mode. He is still there. He can run everything that he wants. He can even take the portion. If you looked at the autopilot screen that he had, you'll see that he can actually switch on some of the fans and make the Petuum run it, and some of the fans he will control. So all those things are there. We use the asset framework and the asset analytics part of that, and then the Pi Vision custom controls. Finally, we are working with OSIsoft for the OCS integration. I'll skip this one. Benefits of industrial AI, you have already heard it, but due to time, why don't we come in here?
Well, we're running out of time, so I'll try to go fast here. Oh, okay, good. So, going into what was the main challenge, the solution and the results, the main challenge was that we wanted predictable, repeatable, golden day of operations, obtaining high yield, high quality, low cost, and sustainable. To prove if the artificial intelligence or machine learning capabilities to optimize our process, if it was something that was still too academic or was something that could be applied successfully to our operations. The process is a very complex process. We have a lot of variables in there. And the complexity is that even the weather, material chemistry, and something that happens way before the material arrives to the system can have a big impact in there. So we have a lot of complexity in there. And today, or up to that date, we didn't have any real-time predictions. And even the very first efforts we had were not good enough. So we wanted something better. The solution was by far Petuum Industrial AI. It taps into the Pi system and other sources to deliver not only the forecast and the prescriptions, but it can also now, as you saw, it can operate one of the sections of the kiln. The second advantage, and as you saw in some of the slides, was the integration with OSIsoft Pi. It was a seamless integration. We didn't have to deliver or to build an alternative solution or build new screens or a new system for our operations, who are already filled with screens in the control room. So having the integration and be able to leverage on all our investment in the Pi platform is something very good for us. And results. The very first tests look very good. The expected improvements after we implement the different autopilot models that we are working on, we expect yield increase and energy improvements between 2 and 7%. Maybe more, but this is I want to be conservative or realistic on the values that we get, and there are other I would say softer benefits, which are process stability, which we have already seen. The way the system is operating right now is more stable, the changes are more subtle. So in the end, that will also give us secondary benefits on maintenance and equipment downtime reduction. For variables or measurable variables, for example, the secondary air, when the system is running, we can get a differential temperature of 100 Fahrenheit degrees higher than we usually have on average from our kiln operators. For tertiary air, which is a secondary stream, we had an increase of 15 Fahrenheit on average. The clinker temperature, the output temperature of the clinker when cooled down is not as high. Still, I mean, didn't decrease. It even was higher by 5 Fahrenheit. It was a very acceptable change because the big benefit is on the secondary air side. On the lessons learned, and this is my final slide, one of the key items is we need company commitment at all levels, from the corporate side, from the plant leadership, to have a successful implementation of new technologies. These new technologies are hard to adopt from a cultural point of view. So, and that will give me to the last mode. But in any case, the corporate commitment and the commitment that we have from Petuum is outstanding, and this has helped us achieve to where we are right now. Second, the AI is not magic. The auto-steer mode, when we first started running it, it was only under very stable conditions. I would say that in some new implementation, it's like that. We need people being there to stabilize or to help the kiln operators in the supervision of the model. We are running in supervised mode. The subject matter expert is key to improve the modes of operation. If you are driving your car in a highway and then suddenly you hit a dirt road, it's a whole complete different set of operating conditions, and the system needs to adapt to those. So we need subject matter experts to do that. And last, the reliable sensors and data are critical. We have had some issues with sensors that we had to turned off the auto-steer mode for 1 or 2 weeks while the sensors are fixed. And we are continuously learning on how to improve the model and how to improve the reliability of our data to be able to run this. And the change management. Our goal is definitely to run it round the clock, 24/7. Support is key. We have people very committed from CEMEX's. In the case of Mexico, we have the Central Control Center, or Central Command Center, which have the capabilities to monitor and operate the plant. In the case of the Corporate Center of Excellence, they are supervising and aiding with analysis and what's going on, how the equipment is operating while the auto steer is on. So support is key, and that's on our side. On Petuum side, we are working with the live tracking and alerting 24/7 to make sure that the system can run continuously, that the data is flowing correctly and everything. And we are still developing and working on a good change management process to make the transition to these technologies better. And in the case of having a team and the commitment, I can say it's not only, I mean, Prabal, myself, we have Edmo, Carlos, Manny from our operations working directly in this. So it's been a wonderful experience so far. We are continuously learning, and hopefully by the time we reach the 22 vision of having an autonomous kiln, we will be at a complete different level with better people trained with analytics capabilities and so on. So from our side, this is it. It was a very good experience, and thank you for having me here. Thank you for having Prabal and joining us here. So if you have any questions, we'll be glad to take them.
Just a two-part question. Norm Doucette from Vale, Canada. Two-part question. Just wondering, in the running the autopilot, did you guys run that in the cloud and then feed that back to the on-prem Pi system, and then the set points were written to an OPC UA server back to the control system? Is that how that worked?
The way the system works is from our, since we are talking about a global deployment, the way we are working right now, I don't know if that's going to be the final architecture, but for now and for this test, what we did is from the local Pi system, the variables were sent to the central Pi or to collective Pi, and from there via Pi Cloud Connect to Petuum's AI engine. From there, it was processed, sent back to our, it was two-step. That's why I'm saying that I'm not so sure that that's the way final architecture will be. But right now, it goes back to our central Pi, from the central Pi to the local Pi, and from the local Pi via OPC, it goes back to the control system.
And from Petuum side, we're also cloud agnostic, and we can deploy in any cloud. And also, we are working on premise on the edge. So from that perspective, when we go into there. But that's the deployment that CEMEX had.
Another question here.
Good morning. I'm Franz Meschberger, coming from Austria, Mondi Packaging. So most likely we know each other as a customer and supplier. But the question is, we are driving lime kilns, similar like your clinker burning equipment. Question is, I did not hear anything about fuel. You were talking about all the preparation of clinker coming into the kiln, and then you have had your ready product.
Yeah, let me go real quick to the schematic. So the very first test that we were doing was the cooler section. We are working now on developing additional models. So a second, we already have a model working here, and we are deploying a model for the kiln power stabilization. Then we have another model that has to take all the preheater tower process to avoid blockages and to provide process stability. So after these three and everything is interconnected, there is a fourth use case that has to do with fuel optimization. The fuel mix optimization takes into account, I would say, three main axes. One is production yield. A second one is fuel, the alternative fuel usage. And these objectives can sometimes be conflicting one another. Sometimes it's a business directive to maximize yield because you're in a sold-out market. Sometimes it's on the alternative fuel usage because of strategic reasons. And then the third one is fuel cost. So you have to take into account, so as you start putting more variables into it, it becomes more and more complex. And sometimes if you want to add more alternative fuels, then it will have a huge impact on how the system operates. So you have to take all of those into account. That's why we're putting that in the longer terms after we do all of this, because these are I would say prerequisites for the other one.
Thank you. So we cannot copy. We cannot copy anything of lime kiln fuel optimization from your part.
Well, I would say not copy, but the...
No, it is not as easy.
The methodology is there. I mean, it's something, and even within CEMEX, or even though we have the exact same kilns installed in different countries, they behave completely different, simply because of the material mix, fuel mix, and everything.
Yeah, thank you.
Thank you. Another question here.
Yeah.
My name's Chris. I'm with OSI. Just very briefly on your roadmap, there was a slide with 5 items on it. Towards the end of it was future data sharing with your community. I was curious with the industry that you're in, with the industry that CEMEX is in. Who do you most want to be connected with closer from an information standpoint with? Your supply chain, distributors? Who are you? What's kind of
The answer would be our customers. We're a customer-driven company, and definitely has to be it has to be the customer. In the end, say for example, quality and product design. That's number one. Or people, safety. That's also number one. I would say people, safety number one, customers number two. To achieve that and to have a better process and a better product, we are doing this to help stabilize that. But who do I want to connect with? Customer, that's it.
Thank you.
So maybe we'll go for a last question, and then after that, we'll introduce our next speakers.
Hi, Fernando from Tejidos, Brazil. How are you doing? Congratulations for the presentation. It was very good.
Thank you.
My question would be, continuing from the first colleague's question, when you work on a cloud-based AI platform, how do you deal with latency in terms of real-time control?
I'll leave that to you. Yes. Slow enough. So this is just not one ML model just deployed at some VM in some cloud. There's a whole lot of engineering has gone in for the last 3 and 4 years in developing what we call a Petuum AI Symphony platform. And so we actually have agents in all levels, and we can also deploy in anything. In this particular one, we were deployed at the cloud, and we took care of all the other things that you were talking about, the latencies and all. So the data is still flowing. So Pi Cloud Connect we are using right now to get that data. That may not be the final deployed architecture. We might actually go directly to the Pi server on the edge. There is also Pi Edge that we are also looking into. So right now we didn't see any of the latencies, issues that we're talking about. But as again, what we're saying is that there's a lot of the things that we have developed in our platform makes that standardization, that deployment, and all these things seamless, and makes these things easier. So if you're actually taking an ML model and deploying it, it'll be different. And if you want to discuss that in more detail, just come to our booth or talk to us, and we can go into this. I did not go into this box. I'll go into this tomorrow at our marketplace session, a little bit more detail, what makes that happen. But from the cloud, we are actually supplying that data all through the servers in the plant, through the OPC connector back into the control system.
And just to touch point on that, for example, in the case of the US and Mexico, we have very good, reliable interconnection, so that's not a problem. But when we are starting thinking of going to South America, Central America, or Asia, that might be the case. So we need to think of how, those issues have to be embedded in the solution. That's why we're not so sure that the current architecture will be the definite one.
But from our side, we support both the edge, on-premise, and the cloud.
Very good. So now I can drop the mic.
Great. Thank you very much. Very good presentation.